Hello friends, welcome to another lecture of the first chapter, that is electric field, electric charge and electric field. That is the first chapter of class 12 physics and NCERT physics, right? So this is lecture number 6. So link of the lecture 5 is given in the description box, and here we're gonna talk about Gauss theorem. Okay, so we're gonna talk about Gauss theorem, and link of lecture 5 is given in the description box. Please go through this. And before we start, please subscribe the channel if you are new to my channel, and if you like my videos, and if you understood, and if you think that my videos are helpful, then share with your friends. Okay, so now let's start. Now Gauss theorem. So according to Gauss theorem, the total flux, electric flux through any closed surface S is in free space is equal to 1 by epsilon naught times the electric charge enclosed by the surface, right? That is Gauss theorem. That is phi is equal to integral E dot ds, right? So that is equal to Q by E naught. So this is the Gauss theorem, where E naught is the permittivity of free space. Its value is given by this. This is the value of E naught, right? So hope you have understood this. So here you see, this is the formula to calculate electric flux, and according to Gauss theorem, suppose you have a closed surface and charge enclosed by this surface, then electric flux through it will be given by 1 by epsilon times of Q, that is 1 by epsilon naught into Q. So hope you have understood this. Now let us prove this one. Okay, now you see, suppose we have a closed surface. Let us consider that a surface that enclose charge amount of charge Q, and this surface is suppose spherical of radius r. So it's this r cap is the unit vector along this r, and O is the center of this surface, so we call it Gaussian surface. Okay, so now you see, we are to calculate the electric flux enclosed by this surface. Okay, electric flux due to the charge enclosed by this surface. So now what do you mean by Gaussian surface? It is nothing but an imaginary surface, closed surface, such that intensity of electric field at all points on this surface is same. That is Gaussian surface. So hope you got it. So now you see, this is the direction of the area vector. We have considered here very small element of area, that is ds, and area vector is this, and the unit vector along this area vector is n cap, suppose, right? So now so let me write what we have considered here. Let us consider a point P, suppose point charge Q positive placed at the point O. Let a sphere of surface area S of radius r assume. So we have assumed this spherical Gaussian surface of its total surface area is S and radius is r, and so here we will assume a point P on this part on this surface. Okay, I will come to this later. So Gaussian surface, that, as I have already told you, that it is an imaginary surface, closed surface, where on this surface at all points that electric field intensity is same, constant. Okay, so here you see, electric field due to the charge enclosed by it, that is Q positive, at each point on the surface E is equal to given by 1 by 4 epsilon naught Q by r square, where r is radius, and the r cap is the unit vector along this radius, right? So this is the unit vector, right? This is suppose equation number 1. So here we have considered a point P. This point is P. Here you see, okay, on this small area element ds, right? So now that electric flux through this area element ds is given by d phi vector E dot ds vector. So vector E is equal to, we have got this one, right? From equation number 1 I have written the equation number 1 again. So if you use that equation here, then you will get d phi is equal to this, right? You're gonna have this, so dot ds. So now you see, okay, so we have considered that unit vector along that surface area vector is n cap. So n cap is the unit vector perpendicular to the surface, and it is along the area vector, right? Perpendicular to the surface element, right? So r cap, n cap, these are parallel, right? And angle between them is 0 degree. So r cap dot n cap dot that will be 1.1 cos 0 degree. That's gonna be equal to 1. So we have got d phi is equal to this, right? So hope you have understood this. So here you see, this was the Gaussian surface. Suppose, let me show you again. This was the Gaussian surface, right? And this was the area element that we have taken, ds. If you see the diagram that I have shown in the previous slide, so here we had the point P, and this is the radius r, right? And this is the area vector. Along this we have taken n cap is the unit vector along area vector, that ds vector, right? So ds vector will be is equal to what? ds dot n cap, right? So that is what we have used here. So instead of ds vector we have used ds n cap, right? So hope you have got it, and let me continue from here. So we have got electric flux, this one. So let me find the electric flux over the entire surface S. That's gonna be surface integral of d phi, that gonna be equal to integration ds. So we have to integrate the surface area, right? So then we know the area of this sphere S is equal to 4 pi r square, right? So if you put that here, then what you will get? So this is the diagram with let me draw it again. Okay, so here you see, let me clean this. Now you see, this is the Gaussian surface, and here is the surface element, and we have taken ds here. This is the n cap, right? So this is the point P here, okay? So electric flux through the entire surface can be obtained by integrating this small element, right? And area of this surface is what? 4 pi r square. So therefore phi will be equal to 1 by 4 pi naught q by r square, and integrating ds we will get the area of the whole surface, that's gonna be equal to 4 pi r square. And after cancelling these terms, what we have got? Phi is equal to q by epsilon naught, and that is the Gauss theorem. So hope you have understood this. This is Gauss theorem is proved now. So hope you have understood this, and in the next video we're gonna discuss about applications of Gauss theorem, okay? So where it should be applied and how helpful it is. So those things will be discussed in the next lecture, okay? So hope you have enjoyed this video, and if you have enjoyed this video, please share with your friends, and if you are new to my channel, subscribe the channel and inspire me to create new contents for you. So thank you for watching. See you in the next video.